Have you ever wondered why trigonometry has so many functions? Sine, cosine, tangent, and then the reciprocal functions? Today, I'll show you how all of them make sense using just one circle, the unit circle. The unit circle is simply a circle with radius 1. When you draw an angle starting from the positive x-axis, the terminal side hits a point on the circle. That point has coordinates x and y. And here's the secret. Those two numbers, x and y, tell us everything about the circular functions. First, we have sine theta. On the unit circle, sine theta is just the y coordinate, the vertical height of the point. Next, cosine theta. Cosine theta is the x coordinate, which is the horizontal distance from the origin to the point. And finally, tangent theta. Tangent theta is sine divided by cosine, or y over x. You can think of tangent as the slope of the line that forms the angle. Now, for the reciprocal functions, cosecant theta is simply 1 over sine, or 1 over y. Secant theta is 1 over cosine, or 1 over x. And cotangent theta is the reciprocal of tangent, x over y. And these three exist mainly because they show up in geometry, physics, and calculus, and they don't add new ideas, they just flip the original ones. Let's try a quick example using a familiar angle, 45 degrees. At 45 degrees on the unit circle, the coordinates are square root of 2 over 2 and square root of 2 over 2. To get sine, we use the trigonometric ratio of opposite side over hypotenuse. And to help you remember, I have labeled our previous x and y values with adjacent and opposite. In our case, the opposite side is square root of 2 over 2 over 1. And simplified, it is the square root of 2 over 2. For cosine, we follow the same method. We use the trigonometric ratio of adjacent side over the hypotenuse, which is also square root of 2 over 2 over 1. And simplified, it is square root of 2 over 2. For tangent, we follow another trigonometric ratio of opposite over adjacent, which now becomes square root of 2 over 2 over square root of 2 over 2. For our reciprocal functions, we have cosecant, which uses the ratio hypotenuse over opposite, which is the reciprocal of sine, so it becomes 1 over square root of 2 over 2. For secant, we have hypotenuse over adjacent, which is the reciprocal of cosine, becoming 1 over square root of 2 over 2. For cotangent, we have adjacent over opposite, which is the reciprocal of tangent, becoming square root of 2 over 2 over square root of 2 over 2. So finally, to summarize, we have sine theta, which equals opposite over hypotenuse. Next is cosine theta, which equals adjacent over hypotenuse. Next is tangent theta, which equals opposite over adjacent. For our reciprocal functions, we have cosecant theta, which equals hypotenuse over opposite, secant theta, which equals hypotenuse over adjacent, and finally, cotangent theta, which equals adjacent over opposite. I hope that after you have finished watching this video, you now know the concept behind circular functions. Thank you for listening, and Pax et Bonum.